Okay,
Should I start again?
Yes.
So welcome to this RC tutorial about how to use our workload scheduler resource manager Slurm. It's how to submit jobs to our cluster. We go a little bit about how to get access to it and what you need to do to prepare your jobs. In this talk, we're going to go over these kind of items. It's a long list, but don't worry, it's only 3 hours. So first of all, a little bit of an introduction to who we are. If you've not heard about us, what we are, how we existed. I wanted to go to the whole thing.
Oh, okay.
No, it's fine. So we are the Research Computing Center. We started in 2007 under the Department of Scientific Computing. This was after they replaced the old IBM mainframe computers, and this was money by the then provost. So we started in scientific computing, but in 2013, we kind of changed our mission to expand our user base, and we became a central part of ITS as a central unit. We administer our main task, worked for a long time, managed the HPC supercomputer. But we also do other things like consulting and provide storage systems. So one of these things that separates us from regular computers is that we provide a lot of specialized hardware. Our HPC cluster is strictly dedicated to kind of remote, kind of cloud kind of applications. So we have a lot more cores than your average home computer. We have some statistics, but roughly 70,000 cores, which is like a lot of desktops combined. We have a lot of just different architectures. We use Intel, AMD. We don't really prefer one over the other. We just want to look at what's the best performance for the right price. And we can, for example, have custom machines, host custom machines for you if you have a grant for whatever specialized FPGA, GPU, whatever type, we can host it in our systems. Now, what is so special about an HPC or cloud computer? In general, if you run a program on your laptop, it will start, but then you close your laptop to go home, it will stop. It will just pause, your computer will just pause it. On our system, you submit a job, you just walk away, and then the next day, the next hour, the next week, or if it's very long, 90 days later, you'll get an answer back to your job. So it's kind of offloading it, and that's the whole definition of a batch process. Instead of that you're interacting with it, you submit an application to the cluster, and at some point it will run, and at some point it will finish. And this is especially nice if you have a process that needs a lot of different iterations. You can think of a bootstrapping process, statistics, an engineering and Markov chain where you have several different steps. You can just change a little parameter, run the application again, and you can do it 1,000 times at the same time. Well, not the same time, but say when there's resources available. So instead of running one program and the next iteration, and next iteration, next iteration, you can submit so many jobs as possible, and then at one point it will all finish. So you can run a lot of different mutations of your own data set. So let's first go over some of the definitions so we kind of know what we're talking about here. So I keep talking about an HPC job. An HPC job is a number of different things together. So in general, like also with your desktop, you have a program, you have input data, which is kind of how you start setting up your environment. If you're doing research, you collect data, you have a program that analyzes it. It can be whatever you want. Then you submit it through some mechanism to our cluster, which is just a bunch of nodes together. Now, this can be on campus, this can be in Amazon, it's all the same. An HPC job is more or less like this. So you collect all your data, you have your program, you submit it as one job, and at the end, you get a piece of output, which can be a text file with one number, 42. It can be a graph, it can be another data file that you go feed back into another program. But in general, this is the kind of the standard HPC workflow, research workflow, where you prepare your data and you get output at the end. So just to do a little deeper dive, how does it look? So I showed you, you've probably seen all the nice images from Google with a rack with all these servers. this is kind of a schematic of all of our cluster. These are kind of all little nodes, which in this case, imagine this is chassis with like 4 different computers, and each computer has a number of cores of CPUs. Each CPU has a number of cores. We have roughly 665.00 nodes, roughly. And each of these servers has 2 or 4 CPUs. The CPU can have multiple cores. These are all multiple cores. So we have machines that are only 8 cores. Most of these actually are being turned off at the moment because they're old. Our new machines are going to have 96 cores, maybe 96 cores. I mean, roughly 98 cores. So some of these machines, newer machines, are very, very big, very dense. So we started out with each node as 4 gigs per core, and now the new standard is 8 gig RAM per core. So these larger machines have roughly like 784 gigabytes of RAM. You can use it all, or you can only use the small amount. These are all connected with a specific fast data network called InfiniBand. So if you have a parallel job, they can communicate very fast. All these nodes can communicate fast. And the backbone, we're in the process of upgrading everything to a 200 gigabit network, which is relatively fast. But the thing with this is that it's very low latency. You don't really care if you have sent a kilobyte, you don't really care any much if it's 100 gigabit or 200 gigabit. You want to be there as fast as possible, and that's called latency. So just to kind of go into so now you have all these nodes. How do you get your job on there? I mean, you want to pick each node, you want to look at which is available. Thank God there is something called the resource manager. Resource manager, you say, this is my job, this is my program, this is my input data. I want 16 cores, run it for me, I don't care. So that's what this package line is. This package is your little application packed with data. And you say, send this to wherever. So if this is an Amazon thing, your program is packed as a package and you send it up to the delivery system. And sometime it will arrive at the other side. Now, sometimes you want things fast. So you pay especially for the Prime. Well, most people nowadays have Prime, but the same thing is with us. If you want to have fast access, if you want your job to immediately start, latest hardware, you can purchase from us. You can run it for free and it will work, of course. But if you want fast access, then we also have kind of high priority lanes. Just like Amazon, which your little package is immediately in front, it will start. Now, some of the terminology, sometimes you hear people say queue, sometimes people say partition. We call it a Slurm account. So this line is what you would traditionally call a partition. And actually, so this is the partition, but we call the account because you pay for Prime, you call it a Prime Slurm account. So we often call, let's say, Slurm account. That's how the scheduler knows what resource you have access to. But still, we occasionally still call it partition or queue. Queue is a very generic name that people have been using all over. If someone says queue, we call it an account. At UF they call it a partition, but it's all the same. We call it server account because it implies access. Okay. So now we go into how to get access to this, and that will be discussed by Marcelina. Marcelina is the person who actually knows things. She's manager of our application system. Application team.
Okay, so before we jump into how to access the HPC, does anyone have any questions on the stuff that we've previously covered? And then also any introductions? I'm not sure if Paul was so humble as to not introduce himself, but that is Paul Vandermark, the director of the Research and Computing Center. And I'm Marcelina Nogales, and I'm the manager of the software applications team. As we'll get further into it, we'll talk about the services that the software team and the systems team provides. So there's 2 different ways to use the high performance computer. There's the graphical interface, which is open on demand, and then there's the command line interface. You can do this through any SSH supporting command line interface, and then there's also through Open On Demand, a command line interface as well. And so we'll specifically be focusing on the command line interface, but we'll also be switching back and forth between screens, as to kind of give you a glimpse of what those are gonna look like. So for our Open On Demand application, we have a desktop, so you can have like a desktop version that looks very similar to what your local machine looks like. But you'll be directly interfacing with the high performance computer. You can open up a terminal, you can open up a file explorer, so that way it's a very easy way of interacting with the high performance computer. We'll switch over to the screen really briefly for what Open On Demand looks like. And I can kind of show you all the different features of that. We have a couple different ways of accessing it if you want an application specific thing through Open On Demand. So for example, if you're using MATLAB, exclusively MATLAB, you can have MATLAB Studio up. You can have Stata. Visit is something that we also do for not benchmarking, but other
Statistic, yeah.
yeah, statistics. Jupyter Notebooks, our Studio server. We also have Spider as well as like a similar interface to our Studio, but for Python. And then a couple different visualizations. So if we go to OOD, I'll briefly, I'll shift over. Yeah, so if we go over to OOD, we'll talk about, I got it. I'll talk about how to get an account later on in the talk. Tab and modification. So essentially how to access Open On Demand is you go through, you're either on FSU Wi-Fi or you're on the FSU VPN. And here are all of our different interactive apps. And you can also access all of your files that are on the high performance computer as well. And then the interface that I was mentioning that is very similar to the command line interface that you would see if you were to SSH in. This allows you to go directly to the login node and access that same information. So we do offer a specific intro to Linux course that kind of delves into how to access the HPC through intro to Linux and like helpful commands. And we'll do a little bit of that here just because intro to Linux is our fall offering of this, a slightly similar course to what this is now. Essentially you connect using SSH, which allows you to again like access that same set of information that you would from Open On Demand. It's just a different flavor. So we'll go into how to submit a non-interactive job. So basically, like Paul was saying, once you close your laptop, you can no longer access a program that's running on your local computer. So if you're submitting a non-interactive job, you kind of just send it to the HPC and then wait for the results to come back to you. And this process, as we go step by step, will allow you to transfer your data and your program to the HPC, run that code, and then send it back to your local computer. So this covers the 4 different steps that it requires to submit a job on the HPC. So both transferring your data and program and then transferring that output. And then there's the added element of creating a Slurm script. So I'll dive into transferring your data and program first, and then we'll talk about what exactly a Slurm script is. So we have a couple different ways of doing data transfer. So you can do SFTP, secure file transfer protocol, directly from the terminal. And then you can also do Globus, and that's really helpful if you have any external collaborators, or if your professor is working with any external collaborators outside of FSU. It's a really easy way to like click and drag things in a nice interface. Open on demand, as I've previously shown, you have access and you can see your files without actually going into an application in open on demand. But what you can do is upload and download small files. The problem with that is that obviously, as we're going through, and sometimes when you're running your program, you have bigger data sets that don't necessarily fit that smaller requirement. And for that case, we also have MOBA Xterm if you're using a Windows machine, and that can be downloaded on anything, but it's like a mix of the command terminal and open on demand. And you can like kind of drag and drop from your local computer to your HPC home directory. So once you transfer your data and your programs to the HPC, you can then create a Slurm account. Or Slurm script, sorry. Slurm account, Slurm script. So what this is that basically, so Paul mentioned utilizing Slurm accounts. And when you're sending your job to like your program and your data to the HPC, you want to make sure that you tell the HPC exactly how many resources you want to allocate for this particular job. And so a submit script not only runs your code, but it also tells the job scheduler Slurm how much resources you need for that. And we have a couple different requirements as we go through, but the look is very typical of like what a bash script is. So it just has a couple different extra commands in the beginning to tell the resources. So this is what a typical or example job script is. So you want to have a job name, and this is helpful for when you're checking on the status of it. So it can be running, it can be pending once you submit it. And then your Slurm account, like Paul mentioned, is just a -A, and then specifically what the Slurm account is. And the next, within the next couple of pages, we'll kind of go through all of the different elements of this, in addition to any other parameters that you would need to include to allocate those specific resources. Paul mentioned that once you have your, you can have a node, and each node contains processors, and those processors then contain a number of cores. So what you can do is you can just specify the cores, and we'll go into it a little bit later. The sub-step for creating a job script is double checking whether or not your code is in parallel or not. If it is in parallel, then you can do this across multiple nodes, and you can just specify the number of cores that you need. And if it's not parallelizable and you just want like essentially a larger capacity computer than what you have, you would limit that to one node. So that we don't get carried away, and if you know how long things are going to take, you can set specifically the time that it'll take. It has a default time, and that will just be the max amount of time within that queue Slurm account partition. But the problem is if you're requesting for the highest amount of time, you will take longer in line to get on, like for your job to run. So it is helpful if you can specify the amount of time that it's going to take. And that's in the format of like days as a number, dash, and then hours, minutes, seconds with colons in between. And then also as we go through like the general access one, so the not necessarily lower priority queue, but the queues that are free for all accounts, we'll go into like all of the limitations for each of those. And then lastly, I think which is the most helpful is setting the mail type. So since this is automatically connected to your FSU ID, if you set the mail type to be all, and there's a couple different ways of setting it. So you can set it when the job starts, when the job ends, if you experience an error. So if you set it for all, you can get an email when the job starts, when the job finishes, if the job has failed. And I think it's really helpful because it kind of sets like you have a timestamp for when that job has been running. And then of course, there's not really a good way to check, like you can continually check and see like, oh, what's the status of my thing? But that would require you to sit in front of it, like continually enter the command instead of just waiting for it to show up in your inbox. And so that's the preamble of a submit script, and then I'll actually go through in the next following slides on details for each of these. So to check to see if your code is parallel, some of your code needs to be compiled before it's run. So like if you ever see like a C program to compile it into an executable, sometimes you require specific compilers. Your key ones are going to be if you're compiling with MVA Pitch 2 or you're compiling with OpenMPI. And then other parallel programs have specific packages and commands for parallel usage. So for example, Python has a multi-processing module that can be used for creating like optimizing it for parallel usage. And that's across not just Python, but other programming languages as well. So what you want to do if you know that it's already parallel, you can just kind of set it for the number of cores, so that dash lowercase n. If you don't have anything like that, so if there's not specific parallel usage commands, or it's not compiled with either of those two for MPI, I would say add this to the preamble. The sbatch dash capital N is 1. So that means that it's limited to 1 node. And that way you can request however many cores within that 1 node, and it'll act like essentially like a supercomputer, as opposed to trying to parallelize it across multiple nodes with like a limited number of cores. So if you don't run it with this, what ends up happening is your program will duplicate across the amount of nodes, which won't necessarily create it faster, like create the output faster. And you might run into out of memory issues because it's trying to divide each of the different nodes that it's assigned to with like the same program that you want to run. So for example, if you have lowercase n is 64 and it's split across 4 nodes with 16 each of those 16 cores will run like 1 iteration of the program. So it'll run it times 4, right? So if you run the same program 4 times without meaning to, then you might even take longer to run your code. All right. So these are general access Slurm accounts. As you can see, they have different run times and different limitations per each. So for example, the max CPU cores per job differs amongst those. For general access, we have it limited to our oldest nodes, but the trade-off is that your runtime is for 14 days, so you can have it running for 2 weeks. And then for backfill, you can get access to newer nodes, but your limitation is 4 hours. So this is mostly like if you are interested in purchasing some of our resources, then you can test it on backfill or backfill 2, or if you have like a job that's only going to run for a short amount of time, you can run it on backfill and still take advantage of those newer nodes. So yeah, so I kind of delved into this a little bit of like what's the best Slurm account to use per your job. So for example, if you just want to check and see if something works, you can use quick test, and then it immediately cancels because it's only 10 minutes. Backfill 2 and backfill will take less than 4 hours, but since these are shared with our owner partitions or our owner Slurm accounts, so professors that have paid for it, there is that like preemption condition on the backfill one, so if an owner or a professor wants to run a node that's within their partition, your job will get stopped. But you know, it's a trade-off between like being able to run on the newer nodes for a short amount of time or seeing how long it would take in general access. We do have a decent amount of students and professors that do use only our like general access. So there is a bit of a wait when it comes to it. When we have experienced longer wait times, people do send in tickets. And we're quick to respond and kind of figure out to make sure that it's a fair share situation for all of our resources. Okay, yeah, that's right. So the last thing for the Slurm accounts is if your professor has access to an owner Slurm account or owner partition, you can also add those as part of what you have access to. Just make sure that you're enrolled in that group. For this, we didn't necessarily have to set this for our job scripts, but it is helpful if you need more than 2 gigabytes per core. So for example, our example job script had the number of cores equal to 4, so that means that there would be 8 gigabytes total for that job. But the maximum that you can have is 4 gigabytes. So you can, instead of having 8, you could have a total of 16 gigabytes for your job. For some of our applications on Open On Demand, they do have a minimum amount of cores that you should dedicate it to. But for some of this, it's you just have to make sure that the math kind of works out, because if you change it so that the number of cores is 1 and the memory that you're asking for is 5, it'll automatically reserve 2 cores as opposed to just 1. But again, the wait time will increase because the Slurm has to do all the calculations and kind of fix that math. So so after you have the preamble for the SBash commands, you also have to make sure that you're loading in the right modules and libraries that your code needs. So for example, some code requires the GNU compiler or requires an Intel compiler. And so that we don't have these automatically loaded in for each and every user, which would completely bloat and like slow the process down, we have it on a module basis. So you can module load different versions of GNU, different versions of Intel, and then in combination with your MVA Pitch 2 and your OpenMPI if you need it for your code. So you could do module load GNU, and that would give you the default version, which is not necessarily the latest version. When we run, there's a command that you can see all of the different versions and all of the different modules that are available called module list. And then you can also do that specifically for a specific software package. So for example, if you wanted to see all of the different versions of Intel, you can do module spider Intel and see all of the different versions for that. Yeah, so the other thing too is that if you have specific things that you're compiling and then you want to ship them over to the HPC, it's safer to know that they compile properly on the HPC before you run your code, and you can also do this within your bash scripts as well. Oh, okay, well then this is just an iteration of what I said before. So module avail, actually module avail is the one that we're using to see all of the ones that are available. Module list is actually the ones that are currently loaded. So for example, when you open up the login node or access the HPC, it automatically loads a couple of these for you. But it automatically loads module load GNU. If you need Intel, it'll automatically take the GNU off and then load the Intel. So there shouldn't be any conflict in modules. Okay, so we talked a little bit already about the module load command. You have to put this in your job script because it's not gonna replicate the environment that you have on your computer. So this is kind of just like, here's everything that you need to run my code in a way that like I could run it on either the login node or my local computer. That we just want to give it as much information as possible. And then when you're running your code, if it's an executable, you can do // or the specific location for it. Since this code will be run in parallel, we use srun as opposed to MPI run, which you might have seen in other different iterations of this. And I think that's it. So that's a lot of information for a submit script. We have a program that allows you to kind of generate it, knowing all the different parameters at this location here. It has limited syntax checking, so you do have to kind of double check to make sure that everything it's writing is correct, but there are different templates available for some software.
Want me to show it?
So I told you that it's possible that you need the job name. And then the extra stuff that's on there is mail types automatically generated. The number of cores is a later feature. It defaults to 1 hour, and then it automatically goes to the general access queue. So what you can do is you can select the specific HPC partition or Slurm account, as we've talked about. And it'll have on there, you could click on that again. The HPC partition. So if it has a key next to it, it's locked. And then if it has a, I believe if it, so if it has checks, then you do have access to it. Because if you try and submit to a partition that you don't necessarily have access to, you will get an error. Or your job will be sitting there in queue stuck. So yeah, so this is the way to do it, because again, we went over a lot of different commands. We also have a Slurm tutorial on our documentation that runs you through even more features than this, and then the Slurm web page itself, documentation, will go through excessively more than what we have. So yeah, are there any questions about this? Yes.
So if you want to have it mail like at the start and the end, but nothing in between, would you create like another dispatch mail line, or would you just like comma, yeah, like that, comma, yeah, okay. See, you did it.
Yeah, so, but yeah, so this is why this is helpful as well. So like you could go through all the documentation to kind of like figure out what you want, or you can like automatically generate it using the submit script generator as one of our team members, Alex Townsend, has coded up this for us. All right, any other questions?
How do you get this one?
We're not there yet. Okay. So I think that's it. And then the next page is just a little bit exactly what it looks like. In case we didn't have time to go through the tutorial demo. Okay, so like I said, for transferring your data and program, you can transfer that Slurm script that we've created on that different application in the same way that we transfer our data and program. So we can use Globus, we could use the terminal, and then we can also use MOVA Xterm, I think rsync as well. So a bunch of different ways of doing it. So at this point, we've just created the Slurm script and we have our data and program on the HPC. So what is the command to submit the Slurm script? So 3 easy steps. If the shell script or the submit script is already on your HPC, all you have to do is log in there and make sure that you're using either your RCC username, or for sometimes we do give workshop accounts depending. So SSH into that login node, and then sbatch the name of that submit script, and then you can check the status of your job using SQ-meet. So the next slide is a GIF of that in action. So we're going from the local computer and we're logging in to the RCC on a login node. And sometimes it takes a minute and you'll have a lot of text that pops up. Once you see that $sign again, you can start typing again. And currently what this is doing is it's shifting to that folder that has the .sh file. Once you submit the .sh file, you'll have a prompt that says submitted batch job, and it'll give you a long line of numbers. That's another way of finding that particular job if you've submitted a bunch of different ones. And then if we go to the next page, we'll see, yeah. So the other thing with this is typically when you're running things on your local computer, once you run the code, your output will automatically start printing to the screen if it doesn't print to a specific file, right? So for this, since we're having a non-interactive, it doesn't make any sense for it to start printing out to the screen because you could lose it, you could not be looking at it. So what this does is it prints all of the output that would normally print to the screen to a slurm-jobid.out file. So that job ID that's printed out when it says submitted batch job is going to match that number on the output file. If there are any errors in your code, it will print out in that .out file, unless you specify a different file. And this is something that's really helpful for if you're stuck in your code and you're not sure why an error is occurring. You can always send this file or the location of this file to our support team, and we can help you kind of figure out what's happening with your code. And it also gives like a little bit of a bird's eye view of like, here's the error that I'm experiencing, here's the job that I'm running, because then we can kind of see from there what like your submit script looks like and that kind of stuff. So lastly, if we do get the output that we want, we can transfer that output to the local computer in the same way that we transfer the data and program into the HPC. So you go to the next slide. It's Globus, secure file transfer, open on demand files if they're small files, and then MOBA Xterm for Windows. Okay. So yeah, before we jump into the particular example, does anyone have any questions on that process? And then also, are there any questions online? Yes.
Raj had a question about transferring data from Azure.
Azure. Will we get back to you on that?
We'll get back to him.
Yeah, so Azure is not one of our common data transfer locations, but we have done the data transfer in Azure before.
We have Globus for Azure, but that's.
Yeah, and we have Globus particular for Azure because it connects to a lot of different applications. Are there?
But let him send a ticket support.
Yes, but feel free to send a ticket to support@rcc.fsu.edu to let us know. Are there any more questions in person or online? Okay. All right. So our example is given a program, a C program that calculates the integral using the trapezoid rule. This can be compiled with different compiler combinations on the HPC. Once you compile it and before you run it, it can create a parallel program. So, yeah. So what that looks like is so this is an example of a program that can be run on the HPC, and it can also be run just locally on your computer. So Once you compile it, so you would module load, Intel and then MBA pitch 2. And then we can check which ones are loaded by using module list. So modulus looks like that, and then you can see that Intel 21 has been loaded, and so has MBA pitch 2 2.3.5. And then what's the, go ahead. So basically you can compile this using MPICC once you load MBA pitch 2, using that trap.c file to create the executable. And now you should be able to run the trap command, the trap executable, and that's the output that you get when you're running it directly from the login node, or you would be running it from your local computer. So if we look at the trap.sh, we'll just jump back to the, we can jump back to the presentation instead of going through all this.
You don't want to type?
No, it's in the presentation already. Yeah, well, can you go back to the presentation?
Yes.
So. Okay, so that's the program, and then once you combine it, you can create a trap executable, and this is what the trap.sh would look like. Again, has the minimal features of the job name, the general access queue, as our Slurm account, the number of cores, the time, and then the mail type. To making sure that we module load the same ones that we use to create the trap executable, and then doing srun trap. So once we submit it, we'll get the submitted batch job with the job ID, and then we can then do sq-me to check and see the status of the job running. For this one, for sq-me, it will only show the running jobs, but we do have an RCC tool that will allow you to see the past 50 jobs that have run and kind of see the different statuses. So like completed, timed out, out of memory, failed, that kind of stuff, pending. So sq-me is if you end up submitting multiple jobs at the same time and you can see them running. If they disappeared from that list, that means they've finished. So, so the top is the example that we saw of running the trap executable in login node. As you can see, the number of processors is 1. And the estimate of the integral matches the one from the bottom. So for this, we just took the Slurm output. And as the slight difference is that the number of processors you can see is now 4 because we did n, lowercase n is 4. And it gives the exact same number. So that's what you would expect, and that's it's helpful to know what your expected output is going to be when you run it, because if you run it and you get something slightly different or something out of the blue, then we can kind of diagnose it. But you could also just like run with the incorrect data for a decent amount of time. Okay, so yeah, so does anyone have any questions on submitting non-interactive jobs before we jump into interactive jobs? Anything from online? No? Okay. So how to submit interactive jobs, we will just briefly touch on this as we go. So there's two different ways to do an interactive job. There's open on-demand interactive apps, and then Paul will tell us about how to do it through the command line using --pty. As we go, and I already kind of mentioned open on demand, but we'll jump into the interface as well. So, so you have the virtual desktop environment, but you also have the command line front end that you can utilize as opposed to having your own command line terminal open. So that's particularly for Windows, because if you open like the terminal versus the PowerShell, like you'll have different commands going in. This way that kind of saves you the hassle if you just log into Open On Demand. You can submit jobs through the web browser, and you can also check the status of the running jobs. And you can do that through ood.rcc.fsu.edu. Here. So when we look at the interactive apps, we will slowly see. It's formatted in the same way that you would submit a non-interactive job. So it's asking you for your Slurm account. It's asking the number of hours, the time. It also additionally asks for the amount of memory, the number of nodes, cores, and then whether or not you want a GPU. And then if you would like to receive an email when the session starts, as opposed to like starting and finishing, just because this assumes that you're going to be interacting with it once it has started. So as you go through different applications, it's kind of the same format where it'll have different extra versions. So like MATLAB, depending on what version you want. So for Jupyter Notebooks, it will also have what Python version you want. And then same for RStudio. But RCC Desktop kind of has it open to whatever you want to run because it's opening that desktop version to access. So once you launch it, you'll get something similar to this, where it'll have the status of the job. The time requested, once it goes to a running job, it'll switch to time remaining. And you can basically exit out of this, like drive home, do whatever you need to do, have dinner, come back, and still access it if it's within that time frame. And it'll be just like you left your computer on. So that's what the desktop looks like. You can access that same file system. Because this is all the same interface, but just, or all the same, connected to the same data, but it's just a different flavor of interface to mess with. If you're interested in more about Open On Demand, we can talk about it just because we do have a decent amount of time. But we also have an HPC driver's ed that goes into what's happening for the terminal if you're just getting started, what's happening with Open On Demand, what's happening, like helpful tips and tricks for if you're working with R, MATLAB, or Python, and then typical troubleshooting stuff that we'll talk about later. We did just launch this, so if you have any feedback on it, let us know. This also allows you to have like a certification as if you were getting like your like computational driver's license. So that way we know that you can navigate the high performance computer, and it allows you to like, there's also quiz elements of it to make sure that you're retaining the knowledge of each of the modules. And yeah, so if this is like something that you're sorry, for HPC drivers, that if something like this, like a in-person workshop, is more helpful to you, not only does it link to our documentation, but it also has videos of our software team member Jose Hernandez talking to you and walking you through those steps. And the videos are like, I guess, minimally like 2 minutes, upwards of 10 minutes to like walk you through each step of the process. Yeah, so that's it for open on demand. If anyone has any questions, before I shift it over to Paul for dash HPTY. Anything online?
There you go. So I always struggle with this part to explain it properly, because this is one of the easiest part of Slurm and also the most confusing parts. As you may have seen, when you submit a parallel job, you use srun. And srun starts n copies of instances of a program. Srun can also be used to start interactive processes from the login node. So it's actually srun is two-faced and they're completely different. Well, not completely, but they are kind of similar. So sometimes you want to run a program in parallel, but you don't want to use you don't want to have the overhead of open on demand. For example, if you have a program that needs to be debugged and you use TotalView. TotalView is our debugger for parallel programs. And the easiest to start it is just it's also an open on demand nowadays. Everything now is an open on demand. But imagine if you want to run it just a command line on the compute nodes. In that case, you can use, or if you want to run a parallel R session, you can use R srun to run R on the cluster interactively. Or MATLAB for that matter. You can run interactive MATLAB without the GUI. Because sometimes MATLAB is nice for a GUI, but it's a lot of bloat. And if you really just want to have a small MATLAB program that you want to have 8 threads with parpool, and you can use it, you can run it with srun, or the new way is salloc. There's subtle difference. So let's first go over srun. Srun, if you're using the script, it will start n instances of the program. The same thing with srun if you run it on a computer, the login node. If you run srun-n for my program, it will start 4 independent instances of the program. Now that's nice if the program is parallel, but what if it's not? There's a flag called P2I. P2I is from the old Linux days physical terminal, which basically allocates that can interact with you. And the confusing part is here you can say srun-n4-P2I program will start that program once. So here's my thing. If you want to run interactively, you use --P2I. And what happens is it will start the program, but kind of keeps the connection open to you so you can type text. So if I do srun-P2I R, it will start R on the login node, or on the compute node, and I can interact directly with the R commands. What it does, it kind of takes the input, it just starts R, or in this case bash, and it will just, as if you're logged into a compute node. salloc does something similar, except you stay on the login node, and you have to run srun to start a program. So you can say salloc-n2, it will allocate 2 cores, it will start a job, but it will keep you on the login node. If you want to run something on that, you do it will start a session for you. You say srun, and then it will run that program. Okay. This is something that you really have to play with, because the principles are very simple, but the practical approach can be confusing. You can say salloc and allocate 10 cores, but you still stay on the login node. And then if you use srun, it will run in those 10. We allocate 10 cores and it will run into it. But for now, we just focus on srun, and I think there's the next one is an example. So srun will start a job, not by default, not interactive. So if you use --P2I, it will tell Slurm to kind of connect back to the login node and allow input. You get output, you always get output, but P2I allows you to input to the program itself. So in this case, I tell Slurm to use the backfill 2 account, for in 1 hour, 16 cores and 2 GPUs. And I run the bash shell on that GPU node. So this will start a job on a GPU node. We'll allocate 2 GPUs. GRES is from general resource. It will ask for 2 GPUs for 1 hour time. And it will run the script. So what this does is you will get a prompt that says something HPC I36 blah blah blah, and you can do an entry and via SMI command, and you'll see that there's 2 GPUs available for you. So if you want to run an interactive job on a GPU node, this is how you would do it. Now, there's not that many GPU nodes in the general access, so this might take a while. So if you submit this, it might say requesting resources, and it may sit there for 5 minutes, 10 minutes, maybe an hour or longer. So, yes. So that's it. So like I review, so we have srun, salloc to run interactive jobs. Srun is also used in bash scripts to start parallel process that you submit with that bash. So to what we've encountered so far, we gave some of the definitions of what we see as a job. As a job. What's a job? A job is like a program, your input data, how to submit it, and the output. What we covered is how to submit non-interactive jobs with a job script generator. Like I said in the beginning, if you look at the cluster as like these shipping lanes, you can see a job script as an envelope. It will tell you where it has to go to, and then inside is a little letter that says, "Hello, dear Slurm, I want you to run my program called Trap with this and this way." So then we went over how to submit interactive jobs with srun and salloc. I would usually tell people to use salloc, but it may be confusing in the beginning if you start, because you allocate a job, but then you get the login prompt back and you don't know where you are. So to check if your job is running, so you submit a job with sbatch or srun, and to check if it's running, you can use sq with the flags -me, or just sq, and sq will give you a lot of lists of stuff. So one of the things we didn't tell you, sq can also show you everything that runs in your specific Slurm account. So you can do sq -A and then genag or backfill. That's it, right? So if Martina just types sq -A and then let's say backfill 2, then this is all the jobs. Now it scrolls so fast you don't see it. This is also the jobs that are not running yet. So PD means it's waiting for resources. There's a number of jobs, and most of the time you'll see an R or PD. And if it's not running, you'll see you can see a reason. Sometimes it's like if you're part of a group, the group has submitted too many jobs. If your professor bought 100 course and you submit for 200 course job, it might give you a reason like, sorry, it's usually a very critical message, but it's like resources exhausted. If it is running, you see one or multiple host names in the end. Almost all of our computer nodes are called HPC, some letter, and then these are actually physical locations in our data center. And what you can see here is the partition, the name of the program, the user, if it's running, and how much time the process has been running. And I think that's. So now we're getting into, since we have plenty of time left. So Slurm. So these were all the kind of the introduction to Slurm. The Slurm has a lot of, if you ever look at the main page of Slurm of sbatch, you see like pages long, it's like War and Peace kind of length kind of options. So, oh wait, did we forget this?
I'm ready for it.
Okay, so do I do this or you?
It's up to you.
So we assume that you have access to our machines already. But sometimes you're new here, you follow this because you want to start on it. So how do you start with getting on our system? Well, the easiest, you have to get an account. Just because you have an FSU ID doesn't mean you automatically have access to our systems. So you go to rcc.fsu.edu, which directs to some crazy page in ITS, and then somewhere if you scroll down, it says manage account. In manage accounts, you can either, if you already have an account, you can log into your information, or you can request an account. You see FSU ID login, you use your FSU ID credentials to log in. It will, if you don't have an account yet, it will give you the option of applying for an account. If you don't have an FSU ID, because you're a visitor, there's ways to get an FSU guest ID, which is to sign up as guest, gives you to a page what your sponsor has to follow. Usually takes a day. But imagine you have an FSU ID, you log in, and it will give you the option, do you want to create an account? There's just two types of accounts that we have. It's if you're a faculty or if you're non-faculty, mainly students, because we require everyone to have a faculty sponsor. So it's for accountability. If students leave, then the professor is responsible for your account. So you enter FSU ID, you press login, and it will kind of give you an option to create an account. Okay. So the form has like several options. One is that account group petitions. This is if you apply for an account. But anyway, so if you request an account, it gives you all accounts. It pulls most of the information from FSU systems, like your name, your email address, and you can pick professor who's going to sponsor you. What happens is that your sponsor will get an email say, do you want to approve this person? If yes, and then within an hour or so, you'll have an account on our system. Now, you can go in, if you ever need to change your password, if you want to change your shell, if you do whatever, you can go back to that rgz.fsu.edu and scroll down to manage, or you can just go to that link that we showed here, /manage. So forward. More.
Sermon?
Hmm?
Sermon?
I don't know what it says, so, but keep one page further. Okay, so imagine that you apply for an account, your professor approves. Now you want to get access to some of the special resources, especially if your professor purchased machines, then you want to get access. Now, how do you do that? Like it's shown, you go back to the general information. On your left, you saw all these things like account information, groups, partitions. In this case, we picked Q. And so imagine you're in engineering, you're part of Dr. Uni's group. You search for UniQ. You click more information, let's search all of these. If you click more information, you get a little form where you can request access to this partition. So you click on it, and sometimes your professor doesn't know, maybe it's a big group. I would always advise you to kind of say why you want to have access to it. It's just to prevent phishing. And then you say submit a request, the professor gets the same email. Do you want to approve this student to your account, to your resources? And it says yes. And then a few hours later, you can submit jobs to that petition. It's all automated. We're not part of it. It's a self-service portal. Creating an account, changing the password, requesting access to storage or server accounts. It's all automated, and the only thing is that interaction between you and the professor. Are there any questions about getting an account? Does everyone here have an account? No. So the easiest to sign up is go to rgz.fsu.edu and scroll down to manage account.
If you take the certification course that you talked about for a little bit, will that get you a way to log in and make an account through that, or is that just more of a learning how to do everything?
It's more of a way of learning how to do it. So the driver's app will show how to get an account. So, yes. You'll get a little bit of credit if you follow the driver's app. That will give you some more karma. Karma will kind of improve your. I don't know.
Are there any questions from online? No. Okay. So shifting back to what Paul was mentioning about the dictionary and plethora of Slurm commands.
So This is just a little overview. I think we still have an online little cheat sheet for storm commands. So this is a little bit of a summary of storm commands. So if you want to submit a job, submit a batch job, you use the command sbatch and then the name of the script. If you want to submit an interactive program, you can use srun or slog. If you want to show all the jobs, not only running and stuff, you can use sq-a, sq-a backfill, sq-a genAC, sq-a rcc. If you want to look specifically at your own job, so you did sq-v, you just see a number there. You can use sq-j, that job ID, it's like a 7-number job. Or you can use s-control show job, the number. They're kind of slightly different, but they both give information. If your job is not running, it might give an error like resources not available or too many cores asked. If you want to cancel a job, for example, that has been running for 2 days, and you look at the output and you think, wait a second, this doesn't make sense. I made an error in my program. You can let it run for 3 weeks and then it will finish at some point, or you can cancel it. If you cancel it, you just free up your own resources, because you may have run into your limit. You can only submit 100 jobs. And if you know that 90 are faulty, then why let them run? So cancel them so you can. There's also, if you want to do diagnostics, if you want to say this is going wrong, this is failing, you can use -info-a, and it'll give you a lot of notes, the names of the nodes. Now, this is not, for most of the beginners, this is not very useful. It's like show me what stones are on the road. So, but most of the time you use srun, sq, or s-control show job. So a lot of the times you think, I submitted a job, but it's not running. So there can be a number of reasons. The main reason is there's just not enough resources available. If you're part of a lab that has purchased cores, your colleagues may use them. And you can say, well, my professor bought 500 cores and there's nothing available. Well, maybe your coworker is running 500 cores. And we've seen that. So, for example, engineering has a large petition, it's always full. So sq-me will show you, give you some information why it's not running. There's a little field in there that says resources not available. You can do sq on that petition to see if it's full or not. If you see nothing running and your job still doesn't start, then you think, maybe something is wrong with the system. And then you can do s-control show job, and it may give you some more information why it's not running. And if it says nodes down, then it's probably time to send help support, which is the next one. If you ever have a question, we try to be as responsive as possible. Of course, if you submit a ticket on Friday at 9 o'clock in the evening, it may have to wait until Monday. But we try to be very responsive with how we can think. So if you have a question, if you have a thing, you can send it to support@rcc.fsu.edu and try to include as much information as you have. Not just it gives an error, but it runs on my desktop. It's try to include what job script did you use, the path to your job script, path to your output file, what you did you load the right modules. Try to include as much as possible. Try to include the error. That sounds easy, but if it says if the error is out of time, that might already be an indication what's going on. But if you said it's get killed, then it takes us time to figure out that you asked for 4 hours of runtime, but your program actually needs 5. So try to include as much information as possible. And so we work hybrid, but we can schedule time to meet with you. So we don't really have regular office hours, walking hours, but we'll be happy to sit down with you and go over what's happening if you need help with any more thing that cannot be easily answered by email. So we do work hybrid. There's usually most of the time there is someone in our office in direct, but it's try to schedule something through this support RTC. We can help you with anything, software installation, maintenance of something, configuration. Think of it, if something stops you from running on our system, we can try to help you. If you say, I need to run on site 6,000 cores, then we may not be able to help you. Although we even then will try to help you, because we've had in the past, occasionally we have downtimes and then the system's down, and we've had in the past where we let someone run for half a day on like 3,000 cores. That's we try to help you as much as possible within certain reasons, of course. And of course, there's the driver's ed, and there's all these courses like this, like the introduction to Linux that we do once a year.
Yeah, so this is our last slide before we deep dive. I'm not sure if you all are interested. We have some advanced topics that we can cover briefly before, since we do have 20 minutes left, but we did want to save as much time for questions.
Who works with NPI? I'm just trying to delete one of the topics here.
Okay,
So there's a few topics that we have, more advanced topics that we can talk about. One of them is job arrays. The other one is like multiple parallel programs at the same time. Job arrays is that if you do some kind of statistical regression and almost all of the input is the same, but there's a slight difference between the different steps. I'm trying to think of a very good example. I use it as a good example.
state of regression.
So state of regression is we have just one little parameter difference. Now you can create 100 different job scripts and all run them individually, or you can do your script slightly smarter, where you check for the job array and then change that, and then you submit just one job. It's one job that's consisting of 100 different steps, which means that it's almost equivalent to submitting 100 jobs, but it makes it much easier to submit 100 very similar jobs. That doesn't make much sense either, but yes, it's if you can have one program that takes just one little parameter that takes it different. So instead of 100 jobs, you submit one job that's slightly different each time. The way you submit it is this: you use @batch and you say an array, where you have an array of 10 different jobs with IDs 1 to 10. And in your job submission script, you look at the Slurm array task ID. And in the past, I had an example, but I forgot it. Some of this stuff is so old now. So if you have a program that needs to run different iterations, and all the iterations are almost the same except for one little slight difference, then task arrays or job arrays are the way to go forward. Another thing is I've seen it especially in Earth and atmospheric modeling. If you, for example, have an ocean model and you have a weather model that are kind of semi-independent. Now you can combine them in one large giant NPI program, but you have two different models that run at the same time. You can also just split them up, but run them in the same NPI communication space. So every time step, so many times that they interchange some data, but then they keep running interactive independently. And that's actually the next one. I skipped one thing. So shared NPI space is basically if you run NPI, you do an NPI communicator, which is usually NPI COM all. In this case, you have two programs that share the same communication space. So you can do an NPI send from one program to the next. And the way you do it is you specify a layout file where you say the first 8 CPUs are for program 1, and the next 68 are for program 2. Now, program 2, if you do an NPI rank to see which one, so program 2 sees 8, that's 15, and it can communicate with the other 0 to 7 to interchange. It's a very nice way if you have semi-independent NPI programs that still need to communicate with each other. Of course, you can put it all in one big program, but then it gets a lot more complicated. Now, sometimes you have multiple parallel slide back. And sometimes you have different programs that depend on the output of another program. So you have a pre-processing step, you have a processing step, and you have a post-processing step. Now, you cannot submit them all three at the same time because the processing step needs the input data, the post-processing step needs the final input data, so they all depend on each other. So what you can do is you submit the first one, it gives you a job ID. Then in the second, you say the dependency is once the first job finishes, then I can start. And then the post-processing, you say I can only start when this step. So you can create a dependency between different jobs. That the next job can only start after the first job finishes. And the third one can only start when the second finishes. No, you don't know when you start what the job IDs are, you only submit when you submit them. So a lot of the times when people use this, they use a shell script to submit these jobs and capture the job ID. But the easiest one is the dependency. If you call your program trap, which we did with our example, but you only want one instance of trap, then you can say, you have to specify the name equals trap, and you say dependency equals trap. That means that there can only be one job running with the name trap. Now, why would you do that? Well, for example, if you submit something to the backfill partition, and you know, well, my job can run for 4 hours, or my job can be killed after 10 minutes. So if you do checkpointing, you submit a lot of jobs to kind of produce it, but you can only have one will run and one will write occasionally to an output file. If that file gets killed, then the next track will start, and so you don't overwrite your checkpointing or your output file. So most of these more advanced forms are kind of esoteric because most people don't use them, but there are some very good use cases for some of these dependencies, the multiple NPI programs at the same time, or the job arrays. If you would go into our currently this, you can. If you look in all our running jobs and you see statistics, there's a lot of statistics students that use job arrays because they have a lot of different, they have the same statistical program with a slightly different iteration. And so you can see that they're running all these job arrays because it makes it easy for them to kind of submit 200 jobs, 500 jobs at the same time with one SPASH command. Instead of having like 1,000 different jobs in this script. So if you have any questions of this, just let me know. And my explanation has been a little rambling because it's kind of it's a tricky subject, all these. But if you have any questions or submit them to support at rcc.actually.
Yeah. So last bit of housekeeping stuff. So after this presentation, we'll send out a survey as well as the slides for usage afterwards. And I do believe, Casey, is the survey going to be up tomorrow?
Oh, wait.
Oh,
Yeah. Sorry.
okay. So yeah, the survey will be up tomorrow. Any feedback would be helpful for this, as we've done multiple different iterations of this. And yeah, and this is actually our last RCC workshop for the spring semester. We have a couple different ones that we'll offer in fall, so keep an eye out for that. I believe possibly in the email that we send out, we will also give you an option to join our RCC newsletter, and then you can hear more information about what we're doing, research spotlights of researchers that are using our system, and the like. So thank you all for attending, and hope you have a good day.